All right, we're going to discuss how to do a one proportion z-test in the video today, looking at page 472, number 25. The dropout rate for high school students in the year 2000 was 10.9%. And we took a survey last year that showed 210 out of 1,782 students dropped out. So with our four-step process for all our hypothesis tests, we're going to start with the hypotheses themselves. So what we have here is the null, and that's our claim. That's this fact that we have that the proportion of high school students that dropped out is 0.109. We're assuming that to be true. And our alternative is they want to know, is there evidence that the dropout rate may be increasing? So the word evidence implies that we need to do a test, and increasing means it's an upper-tailed test. So some common mistakes I want to address right now. These are population parameters in your null and alternative. They always need to be that. So we're not going to see any hats in the null and alternative. That's wrong. Also, your null is always going to be a statement of equality. You're never going to see an inequality there. So make sure your null alternative is always a statement of equality. And we're assuming that to be the truth. So let's talk about some dropouts.
Ooh, dropouts. I know about them. So like 10 years ago, the dropout, well, that guy, he would look like, oh, let's see, I would say he would look like this, right? He's got the cool spiky hair, right? And then he's got the cool shades. That's just cool. Aviator glasses. That was always cool back, what, 1999, 2000 we're talking about? Yeah, hey. What else do we need for this guy? Oh, he's got a dropout. So we got the tear-off shirts and the parachute pants. Those are cool. Yeah. Tight belt. Big muscles from the gym. That's where he's spending all his time instead of working out. And he's making a big muscle for you right there. Hey, how you doing? Boom, boom, boom. He's got the peace sign and shaka. There we go. Oh yeah. Hard to believe I went to art school for all this. And he's the P guy, right?
Yes.
Right. He's number P. P. Excellent. And his buddy over here, he's the guy from 2000, right? The dropout from 2013, so far away. So he has the cool emo hair because he's very, very sensitive. He didn't want to spend time at math. He was too busy doing something else. So he said, I'm out of here. He got the little soul patch there. That's cool. And let's see, what else does he have? He's got, oh, he's dressed dark, and he's got the skinny leg jeans. Got lots of emo friends. They all wear the skinniest leg jeans. Not like parachute pants, the exact opposite.
So girls don't drop out of high school, just boys? Just
these two dudes. This is the archetype. We want the archetype. Lots of chains. I guess I could draw a girl, but I don't know how they dress. Okay, and he's got gloves on. Yeah, big mittens, because that's just cool. I don't know why. And he's the what's his letter?
P hat.
He's P, but he's got a cool hat. So we'll give him a pirate hat, because that says I'm dropping out and I'm a thinker on my own terms. That's right. Arr, I'm a pirate. Pirate hat. Arr. Okay, so the pirate hat guy versus the weightlifting P guy over there on the side who's all cool. So let me just take these guys and move them over to the side. So we say versus. This time it's real. So one of these two is going to end up bigger than the other guy. Or they'll be equal. Correct?
Yes.
No other alternative.
One's bigger than the other.
Let me move him out of the way. You guys, come over here. They'll be waiting here for the result. And, okay, you're back on.
All right, so in step 2, what we need to do is now we need to check our conditions. So let's take a look at that. All right, so just like we did in chapter 19 when we did confidence intervals, we're going to have 4 similar conditions, starting with the random condition. And I'm going to look at the context of the question to see if they said it was a random sample or not. And I noticed that they did not tell me it was a random sample, so we are going to have to assume that the sample is representative of the population. So in this case, that would mean that these dropouts from last year are representative of all dropouts from last year. Okay, then we have our independence assumption. And we're assuming that one student dropping out does not affect another student dropping out.
Oh, it's like he didn't just drop out on a dare from the other guy.
Nope, he wasn't
Okay.
intimidated by the muscle guy.
I see. Just saying. If you told me I had to drop out, I'd be scared. I'd just do it. Find another career.
That's why my class sizes are so small.
Ah, I see.
Okay. Now we need to talk about the 10% condition. Make sure our sample is not more than 10% of the population. So we're going to look at that sample size of 1,782. It's reasonable to claim that is less than 10% of all dropouts last year. And finally, because we have categorical data here, we're talking about our success-failure condition. Now, this is going to be extremely important here. Back in Chapter 19, when we did confidence intervals, we did n times p hat and n times q hat because we had a point estimate, our sample proportion, and we didn't know what p is. Now we have a claim. In 2000, the dropout rate was 10.9%. So this is going to be back to n times p. So it's going to be 1,782 times 0.109 for n times p. And for n times q, we're going to have 1,782 times the complement, 0.891. Let's do a couple calculations here. So this is 194.238, which is greater than or equal to 10. And the complement is...
Oh, you're right on the edge of that zone there.
I'm about to drop out myself here. All right, 0.762, greater than or equal to 10. Make sure you show that both the number of successes and the number of failures are greater than or equal to 10 before you move on to your closing statement here. Okay, so let's take a look at that. Our transitional statement here is going to be your conditions have been met. Therefore, we're going to... Oh, I want to go back to what we were doing in Chapter 18 here for a second. Okay, conditions have met, so that means the sampling distribution is approximately normal, and we're going to use a normal model. Whoa, don't want to get in that guy's hair.
No, he's not a normal model.
For one proportion Z test. It's a test now, not an interval.
Well, I was popping Z's during a test, and I think I failed the class once, so that makes sense. Is a Z test the same thing?
Is that why you're this muscular guy who was on San Diego Beach teaching surfing lessons?
Maybe.
To instruction, everyone.
Oh.
That is not the bell.
Uh-oh.
If I could have your attention, please.
And we're going to pause here. All right, we're going to continue with the question from page 472, number 25, looking at the mechanics part of things, which is step 3 of the 4-step process. So let's take a look at that. All right, so step 3 is mechanics. And we have our mean, our population proportion, which is P, which the claim is it's the percent of high school students that dropped out in 2000 was 0.109. And we have p hat, which is our sample proportion based on last year's sample. We have 210 out of 1,782 students dropped out. And that proportion is, let's bring this up, so we got 210 divided by 1,782. It's 0.118 approximately. So this is about 0.118. Okay, now the next point is going to be kind of really something that you need to focus on. Is now we have our standard deviation of p hat. Now you really need to think about why I'm using standard deviation here and not using standard error. So I'm using standard deviation because we have a claim for the population proportion, the true proportion of high school students who dropped out. Remember, we only used standard error in Chapter 19 when we didn't have a previous claim about P. So I'm going to calculate the standard deviation, which is going to be, in this case, 0.109 times the complement, 1 minus 0.109, which is 0.891, divided by my sample size of 1,782. Okay, let's figure out what that's going to be. So, square root of 0.109 times 0.891 divided by 1,782. Alright, so about 0.0074 it looks like. So our standard deviation of p hat is 0.0074. Okay, so now, just like we've done, we have a normal model here because we're doing a one proportion z-test. That's a pretty amazing normal model. All right, so our mean is going to be centered at p, which is 0.109. This is our sampling distribution that we're taking a look at. And our p hat was 0.118. And the question is asking, is there evidence, and remember that keyword evidence implies to do a significance test, that the dropout rate may be increasing. So I'm looking at a one-tailed upper tail test, so I'm looking at the proportion. What's the probability that the sampling distribution is going to have a p hat that's greater than 0.118? So back over here, I'm going to go ahead and calculate a z-score based on the information I have. So I'm going to take my statistic, which is the 0.118, minus my mean, which is 0.109, divided by my standard deviation, which is 0.0074 equals. Now, I'm not going to need to do any of this work on the calculator, or I'm not going to need to do any of this work by hand because I have the calculator. So let's take a look at how to do that on the calculator. All right, we're going to go to Stat Test, and I'm going to find one proportion z-test, which you can see right here is choice 5. So I'm going to click choice 5. This is my null percentage or proportion, which in our case is 0.109. X, and this is extremely, extremely important. X is always going to be n times p hat. So we already know I don't need to multiply. The number of successes in our sample was 210. So that's going to be my number of successes. My sample size is 1,782. And I'm doing a one-tailed upper tail test. So it's going to be greater than the null. Okay, and then I'm going to go ahead and hit calculate. And this will give me my z-score and my probabilities here. Okay? So you can see here, you have your z-score, you have, this is your p-value, your 0.119, and you also have your p-hat, your sample proportion, which was 0.118 from before. So our z-score is 1.198. So back over here, 1.198. So it doesn't seem like it's going to be very unusual because it is within 2 standard deviations of the mean. All right, so we have our notation to find our p-value. We have the probability that z is greater than 1.198. And bringing that up again, let's take a look at what that was. 0.1154. Okay, so our p-value is 0.1154. Okay, so there are your mechanics. Just remember, when you're doing in your calculator for a hypothesis test, and even back in chapter 19 when we were doing confidence intervals, x, your number of successes, has to be from n times p hat. Keep that in mind. Everything else should be pretty self-explanatory here. So this 0.1154 is going to represent our p-value, and this is going to determine how we make our conclusion based off of what level of significance we're going to be using. So let's go ahead and take a look at our conclusion in our final step here. Okay, so step 4 of the 4-step process for any hypothesis test is going to be your conclusion. And 9 times out of 10, they're not going to tell you in the stem of the question what level of significance to use. Whenever they don't tell you, it's going to be, we're going to assume that alpha is equal to 0.05. And this is not something you need to write. You'll see how we kind of tie this into our conclusion in just a minute. Okay, so there's really going to be, my expectations for your conclusion is there's really going to be kind of 2 sentences or 2 parts. The first part is you're going to talk about what is your p-value high or low based on the significance level, and then the decision you're going to make. Are you going to reject the null or fail to reject the null? So if you remember, our p-value, going back here, was 0.1154. So if you think about, is that p-value larger or smaller than 0.05? Well, it's larger. So if you think back to class today, if the p-value is larger than your significance level, you're going to make the decision to fail to reject the null. So my first sentence here, I'm going to say, since the p-value is, so since the p-value equals 0.1154 is greater than, and I always need to tie it back to the significance level, and I have to literally put that in my conclusion. So you're going to notice me do that here. So is greater than alpha equals 0.05. Or you could say is greater than your 5% level of significance or your 5% significance level. What does that mean? That means we fail to reject the null. So I need to make that distinction or that decision right now. We fail to reject the null hypothesis. Okay, there's our first sentence. Talk about the p-value in comparison to your significance level and make a decision about the null. Well, what does that mean? If we're failing to reject the null, does that mean we have a lot of evidence, strong evidence towards the alternative, or hardly any evidence, weak evidence towards the alternative? Well, if I'm failing to reject the null, there's not much evidence towards the alternative. So what that means is, I'm going to talk about the evidence in the second sentence here. So in this case, there is weak evidence. Oh, let's fix that here. All right, so there is
evidence that, and I need to put it in context. Well, what's the alternative? The alternative was p is greater than 0.109. Well, what does that mean? That the true proportion or the population proportion. I'm always talking about the truth here. I'm talking about p. We know what p hat is. That the true proportion what we got here of high school dropouts is, and the alternative was greater than. So that's what I'm putting here. I'm not talking about the null. I'm talking about the alternative hypothesis. So there's weak evidence that the true proportion of high school dropouts is greater than. Oh, let's fix that mess. Even when you write like a fourth grader, you want to try hard. Okay, so there's weak evidence that the true proportion of high school dropouts is greater than 10.9%. Okay, so I want to answer specifically what they're asking. Is there evidence that the dropout rate may be increasing? Well, no. So it appears that the high school dropout rate is not increasing. Okay, so there's our conclusion. So a couple things. I really have a couple parts here. One, going back to that first sentence, I'm talking about my p-value based, or my p-value in comparison to my significance level. Is it greater than or less than? And that's going to dictate my decision. If your p-value is greater than your significance level, you're going to fail to reject the null. If your p-value is less than your significance level, you're going to reject the null. Again, if they don't state the significance level, it's going to be assumed to be 0.05 always, and you need to explicitly state that in your conclusion. Now, if we had a significance level of 0.1, my p-value is still greater than that, it wouldn't change my decision. If I had a p-value of 0.01, or I'm sorry, a significance level of 0.01, my p-value is still greater than that, I would still fail to reject the null. So in this case, of the three common significance levels, it wouldn't change our decision here. There's not a lot of evidence that the true proportion of high school dropouts is changing. So that's your first sentence. In your second sentence, you're really talking about how much evidence there is towards the alternative, and that's dictated on your decision. If you're failing to reject the null, there's not much evidence. We're going to see in a minute when I talk about p-value in context, there's a little over 11% chance, if the null is true, that I'm going to see something this or more extreme. Well, that's why there's not much evidence that the null isn't true. Okay, so in this last part, let's kind of take a look at p-value in context. And the question in your textbook doesn't ask this, so this is not something that you'd be expected to do unless they specifically said, write the p-value in context. That says value, you could see. Okay, so if I want the p-value in context, here's what that's going to look like. Well, what are we assuming about the null? We're assuming that the null hypothesis is true. So what would that mean? Remember, your p-value is a conditional probability. So that means if percent, let's see, I'll clean this up here. If the true proportion of high school dropouts is 10.9%. So there's the conditional part. If the null is true. Now I'm going to talk about my p-value. So then there is a 11.54% chance of observing a difference this or more extreme by what we're going to call natural sampling variation. Okay, what does that mean? Well, if we take a look back to our mechanics here, this or more extreme, so this or more extreme, so in this case, that we observe a p-hat of 11.8% or higher, if this indeed is the percent of high school dropouts. Okay, well, 11.54%, that's more than a 1 in 10 chance that we see something this or more extreme if the true proportion is 10.9%. Well, that's not that unusual. That's why we failed to reject the null. So one thing to think about is, when would your results be statistically significant? Well, if this p-value, if this happened, say, 0.02% of the time, 0.02%, well, that's 0.0002. So that happens 2 in every 10,000 times. If I see something like that, then there's a lot of evidence that my true proportion is in 10.9%, and then in fact, there's a lot of evidence that it's higher. But that wasn't the case here. We had a p-value of 11.54%. So that's not that unusual. That's why we failed to reject the null. There wasn't a lot of evidence towards the alternative. So we'll talk more about hypothesis testing in class next time. Hope you guys enjoyed the video and you got something out of it.